You can feel the warmth when a bulb, a fan, or a computer is being used. You know that these gadgets are the ones in which electrical energy is converted into some other form of energy. When you look at this fan, here, electrical energy is converted into rotational motion. In the case of bulb, electrical energy is converted into light energy. But not all electrical energy is converted into light energy or motion. In devices like bulbs, the conversion part of the electrical energy into heat energy is undesirable. But there are instances where electrical energy converting into heat energy is absolutely desirable or necessary. If only part of the electrical energy gets converted into heat energy, then how much of electrical energy is required to generate a specified amount of heat energy? Or are there ways to ensure that such a device converts most of the electrical energy that it receives into heat energy? There are some devices that depend on a larger part of electric energy. In case of an electric fan, large form of electrical energy is used to do work as the fan blades keep rotating. Devices like clothes, iron, or heater have a resistive circuit. These devices have only resistors attached to the energy source. Therefore, the source energy is entirely converted into heat energy. Appliances like electric stove or clothes iron that get heated up have wires that are not severely impacted. Suppose an electric iron consumes energy at a rate of 840 watts when heating is at the maximum and its voltage is 220 volts. So first, let us find out the current I flowing by using the formula I equals P by V. By calculating, we get current I as 3.82 ampere. Now let's calculate the resistance R by using the formula R equals V by I. A current I is flowing through a resistor of resistance R. The potential difference across it is V, and T is the time during which a charge Q flows across. The work done in moving the charge Q through a potential difference V is VQ. So, the source must supply energy equal to VQ in time T. Also, the amount of heat produced in time T for current I will be H equals VIT. As we know by Ohm's law, V equals IR, we get heat produced as I square RT. This is Joule's law of heating. This law implies that heat produced in a resistor is directly proportional to the square of current for a given resistance, directly proportional to resistance for a given current, directly proportional to the time for which the current flows through the resistor. Joule's law finds many practical applications in devices of daily use. One of the most common is the electric fuse. The fuse is usually placed in series with the device. The fuses that are used for household purposes have ratings as 1 ampere, 2 ampere, 3 ampere, 5 ampere, 10 ampere. It is made of a material that will melt when the flow of current exceeds a specified level. What happens after this? The fuse wire gets overheated, melts, and the circuit is broken. This prevents fire and the appliance is protected.